report is about one-dimensional numerical simulation for bar grouting in stand column. The first part is the introduction. MICP means microbial-induced carbonate precipitation. It is a relatively new technique of great potential applications in the field of geotechnique, environment, and energy. MICP involves the process of hydrolysis of urea by urease enzyme from the bacterial metabolism activities. And in the presentation of calcium salts, the calcium carbonate precipitation will form around bacterial cells. Based on MICP technology, the behavior of foundation can be improved by grouting cementation solution and bacterial solution in situ, and the behavior includes the mechanical and hydrolysis properties. And the application of biogrouting method involves the liquefaction resistance, the slope stability, the concrete and masonry crack repair, the well drilling construction stability, and the stability of railway tracks, and so on. Compared to chemical grout method, biogrouting method materials possess the advantage of smaller viscosity and higher fluidity, which make it possible to repair micro crack and enhance the effective distance of a single grouting point, therefore reducing the cost. Meanwhile, the microorganism has low energy consumption and low emission, and the bacterial cells come from natural environment, so the biogrouting is hopefully an environment-friendly method. Different from chemical grout method, biogrouting is able to reinforce the subsurface soil in situ without excavation, and the treated foundation retains certain permeability, which means special requirement for ground reinforcement. But there are still some problems about this kind of reinforcement method, including the homogeneity of the calcite precipitation distribution, and the control and maintenance of the bacterial activity, and the condition control of the in situ test and practical application. And the second part is the biotechnical process. The first step is the hydrolysis of urea, and then further reaction can happen according to equation 2 to 9. Except the urea hydrolysis and carbonate precipitation, all the reactions are reversible, so we can calculate the reaction rate by the condition of dynamic equilibrium. And the third part is the modeling of MICP. The factors that affect the hydrolysis rate of urea in porous media includes concentration of urea and calcium ion, pH value, temperature, aging of microorganisms, insulation of nutrients by calcium carbonate crystals. Assume that the influences of certain factors on the reaction rate are independent of each other. Then the hydrolysis rate of urea can be presented as the following equation. And we can also calculate the precipitation rate of the calcium carbonate based on the crystallization theory. And with the increasing precipitation of calcium carbonate, the porosity of porous media will become smaller, which can be described by the following differential equation. And suppose that the soil and solution are incompressible, then in a certain amount of time, the volume of outflow equals to the reduction of pore volume. And the population differential equation can be written as the following. The The fourth part is the finite element modeling of the background. The basic formula is the convection, diffusion, and reaction equation. The three items on the right of the equation represent the diffusion, convection, and microbial chemical reactions respectively. Then we can also consider the absorption between reagents and the porous medium, and use the second formula to for modeling. And describe the length of the column into unequivalent units, and use the variation principle for the finite element analysis of the basic module. And define that the concentration of different ions equals to the sum of the concentration unknowns and the basic formula. Then we can get the following equation. And by follow computation, the equation can be finally transferred to the form as following. And then we can solve the equation by backwards Euler method and Newton-Raphson iterative method or any other mathematical method. And the first part is the analysis of the simulation results. The four figures show the comparison between the simulation and the existing experiments from the literature. And obviously there are some errors. They are related to the assumptions and the limit of the model. And in this follow investigation. Okay, that's all. Thank you very much.